Hello again, and this screencast is entitled How to Determine Doubling Times Using Excel. So this is a screencast specifically for the logarithmic lab report. I have done a previous screencast, which you may or may not have watched, about how to do a growth curve. So if you're not sure of how to get to this point where you've got a growth curve in Excel, you need to go and look at that first screencast. If you have looked at that first screencast, you will, if you're running them through, you'll notice that I reverted this back to being a linear scale, just so we have a little bit of overlap. So as I explained slightly on the previous screencast about growth curves, bacteria have 4 phases of growth. They have lag phase, which you can sort of see here, where the cells aren't dividing very much, they're getting used to the new environment, altering their metabolism, etc. They have a logarithmic phase, which very often is referred to as log phase for short, or exponential phase, where they're growing exponentially. So they're doubling and then doubling and then doubling and then doubling, and that doubling time is fixed. And then they slow down as their resources start to run out. Quite often that's carbon, that's whatever sugar they're growing on. And then this slowing down is referred to as stationary phase. And then they can just maintain themselves and just basically not die but not grow anymore for quite a long period of time, really. So more than a couple of days in the case of E. coli. And then after a while, if you followed it for long enough, they would eventually just start to die of starvation, and that would be death phase. So a doubling time of a bacteria is, as I said, it's when the bacteria are doubling every a specific amount of time. So one of the best known examples would be E. coli, and that doubles every 20 minutes. So it's got a doubling time of 20 minutes, and that is when it's growing at its fastest, and that's when it's in a very nutrient broth, something like LB. It's growing in aerobic conditions. It's a flask being shook, so there's lots and lots of oxygen going into it. It's being grown at 37 degrees, which is its optimal temperature. If you lowered the temperature, that doubling time would reduce from 20 minutes to probably closer to 40 if it was if the temperature was closer to 30. Staphylococcus aureus, that's the fastest you can get that to double, is about 40 minutes. So it depends on the species you're growing, and it also depends on the conditions. So like I said, this is for your logarithmic, so this is how, so your logarithmic lab report, so this is how we're going to determine the doubling times from the graphs that you've got. So if you're up to this point on your own, good work, well done. So what we need to do is we need to make this logarithmic. So we're viewing this data on a log scale, and that's because when this is doubling and then doubling and doubling and doubling, it's really hard to tell whether that's an exponential curve or whether it's that bit or whether it starts down here or whether it starts here. It's really, really hard to tell that by eye. The human eye is much better at seeing straight lines. So what I'm going to do is I'm going to make this into a logarithmic scale, so we'll see this exponential curve plotted as a straight line, and then we'll have a much better idea where lag phase ends and where stationary phase starts, and which part of these two curves are actually where it's actually in log phase. And then only when it's in log phase and it's doubling with a constant speed, it's only that point of the growth curve can we determine the doubling time with. So making this into a logarithmic scale. So I've highlighted it, as you can see the axis has now got this box around it. I'm going to right click, and that didn't work, I apologise, do that again. So make sure you right click within the chart area, the axis area, otherwise it just clicks out of it. So format axis, I would like it to be on a logarithmic scale, please. What happens here is this axis has jumped up to 1, and it doesn't look very good having the axis up here. You want it to be at the bottom. So you can alter that by clicking here so it says horizontal axis crosses. I don't want it to be automatic because it's plotted it somewhere stupid. So I'm going to click on that, and I'm just going to tell it that bottom data point. And obviously that data point might be different for your curve. So for me it's 0.01, but for you it might be something smaller or larger. And I'm going to click close, and it's popped down. And now you can see we've got this nice straight line here. So I'm going to do these one at a time. You might find that you want to do these individually, and you want to remove, because obviously you're going to have 4 for your Lacopron lab report. You might find that you're finding it far too cluttered, so you might want to take one of them off. So I think I will do that with you. So I'm just going to highlight my growth condition 2 and just press delete. And that gets rid of that data series on my graph completely, and we'll just make another graph in a minute to look at that. So where is this a straight line? So I think that this is probably a straight line from probably here, or perhaps here, or maybe even here. Sort of up to your judgment really. So I'm going to go for this middle one. So that's 90 minutes through to 120. So I'm going to highlight that area. So 90 minutes through to 120. I'm going to highlight that in yellow, just so we've got that, so we won't forget. So from there to there. So then I don't want to work with this anymore. I don't want to work with stationary phase, and I don't want to work with this little bit of lag phase. So I'm going to click on my chart series, my line here, my growth conditions one, and it'll come up with this blue box. Now this blue box is telling me what is this, the data points that it's used to plot the x-axis. This sort of like purpley box, this pinky purpley box, is telling me what it's plotted to use for the y-axis. So I'm just going to tell it now. I'm going to move it, and I'm going to say, actually, I just want you to do these two. You could redraw the graph, but you don't need to. You can just get this little square here and pull it up and say, I don't want you to use those values anymore, or those values. I just want you to use those values. Now, that's not done a particularly good job, because obviously it's still using all these time points, so we need to do the same for this. And now I've got rid of the rest of that data. I think that's probably got a bit of a kink on it there, but I'm a little bit, I don't particularly want to use only 3 data points, so I might just extend it to include that last one as well. That 60-minute one as well. I think that's probably a better line. So this is my straight line, so I'm saying here that this graph is now all the data that I've got for this curve that is my log phase data. And because it's my log phase data, I can use it to determine the doubling time. Rather obviously than drawing lines off my graph and like plotting the difference between, I'm just going to get the computer to work out a line of best fit for me that I can then use mathematically to determine the doubling time. So I'm going to do that by clicking on the chart line, right click, add trend line. Now it's saying, would you like the line to be linear, logarithmic, power, etc. And I'd like it to be exponential, because I know by the nature of my growth curve that it's doubling and then doubling again and doubling again and then doubling again, and that is the nature of something being exponential. So I'm going to say I would like you to put an exponential line on it, and because this axis we've changed from being linear to being a logarithmic scale, we're not seeing sort of that curve that it's showing in the picture, we're seeing it plotted as a straight line, which is fine, because that's how we've chosen to view it. We can change it back in a minute actually, so you can see that curve. I do as well, I would like it to display my line equation, and I'd also like it to display my R² value as well, just because I like lots of information. And I'm going to click close. I'm just going to move these chaps over here just so it's a little bit less crowded in that top corner. If we did want to just alter how we view this, again I've just clicked on this axis, right click, format axis, and say I wouldn't like you to be a logarithmic scale anymore, just be a just be a normal scale, you can see now that that line of best fit is that nice curve that you'd expect to see for a logarithmic scale. So now we have our line equation. We can utilise this to determine the doubling time. I'm just moving this so you can just see it a little bit clearer. I've always also asked it to show you the r squared, which is the regression line. So you can use this figure to determine how closely the trend line follows your data. So it gives you sort of a level of confidence as to how closely your data is following the curve that is put in. Obviously, so if this number was really, really low, it would mean that your data isn't really following that trend line very well at all. Whereas if it's very, very close to 1, it means that it's following that trend line very, very closely. In your lab book, you may have seen this page. Now obviously the page number will vary depending on what course you're on. But this is at the back in data analysis, and it says from the graphs you've drawn in the lab, this is how we're going to do things in Excel. So we've done all of this and this is excellent, and now we're here. So we have got an equation and it will be in the form of y equals AE bx, where a and b are numbers. And to calculate TD, which is the doubling time, we need to divide log 2, natural log 2, and that is 0.693 by b, which is here. Now if you want to, right, you can just stop reading right there. You just stop reading, because if you carry on reading, what it's telling you is how we've determined that that is the case. And if you're not mathematically minded, this might make you lose the will to live. So if you want to stop reading there, stop reading there. And that's where I'm going to stop reading at this point, because this screencast is about how to use Excel, not how to work out A-level maths. So I am out at this point. So I'm going to remember that to calculate TD, so the doubling time, I need to go 0.693 by b. And b is just there in my line diagram. So I'm going to go back to my line, and here, this here is my b. So I'm just going to write that down. So b equals 0.0174, and my TD, so my doubling time, and I'm just going to make myself a little equation. So I'm going to go equals 0.693 divided by my b, which was 0.0174, enter. And that is my doubling time. Now it's 39.82759 minutes, and it's minutes because I'm in minutes down here. So this obviously isn't hours, because I can see here that my data is doubling within the time that I've taken to do my experiment. My experiment only took me 6 hours, so it's not going to be 36 hours. So be really careful here of your units. Make sure that they make sense. You can tell roughly what they should be just by looking at your data. You'll be sort of plus or minus half an hour, I think, even if you just guess. So you should know-ish what this number's going to be. In terms of lab reports, I don't think this needs to have this many decimal places. So you can think about sort of how many significant figures you'd like it to be. If we now then go back, I'm not going to go back. I'm going to make another chart. So I'm going to say I would like these to be my minutes, this to be my growth condition 2. I'm going to insert another scatter graph. I'd like it to be joined up. I'm just going to pop it on top because obviously my screen's not terribly large. I'm not going to worry about naming everything at this point, but I'm just going to be really, really quick and just format this axis, make it logarithmic, make my value 0.1 so I can see what's going off. And here the log phase is much longer. So this straight line is much longer, and there's a little bit of a longer lag phase, to be honest, but this log phase is much longer. So I think it's from 60 all the way through, that might be having a bit of a curve there, so I'm going to say to 300. So 60 minutes to 300 minutes, and again I'm going to highlight that. I'm just going to highlight in a different colour so we don't get confused. And now I'm going to truncate my data set just to include those points, and obviously I'm going to remember to do it with my time as well, otherwise it just muggles it up a bit, really, just because we had that break for lunch and it nobbles it on that bit. Right click, add a trend line. I would like it to be an exponential trend line. Again, I would like my equation and my R, and close. Again, I'm just going to move these just to where I can see them a little bit better. For this one, apologies, I probably should have just made that, given that a little title so we don't get confused. So that's growth condition 1. Growth condition 2. And here, my B, this is my B number up here, is 0.0114. And if I work out my TD, I'm going equals 0.693 divided by B, which is 0.0114 in this case. And now my doubling time for this second data set for growth conditions 2 is, if I averaged it up, 61 minutes. And these are different. And if we just go back to that first growth curve we had, that sort of makes perfect sense, because growth condition 1 has a much shorter log phase, but it's growing much quicker, so it sort of gets to sort of the point where it's run out of nutrients much quicker because it's growing faster. And that's the one we saw with the faster doubling time, where the growth condition 2 is just sort of doing a much more slow and steady and is doubling over a longer period of time, we see that reflected in our TDs. So that's all I've got to tell you about how to determine your doubling times. I hope that was helpful. I think occasionally I might have mixed up the words exponential and logarithmic, and I apologise for that if I have. Yeah, sorry about that. I'm going to go through and see if I can find them and put little notes on for you. Yeah, so thank you very much. Yeah, thanks. Bye.